Ladies and gentlemen, good evening and welcome to another session of the Nambane Academy Grade 12 Physical Sciences 2024. And we are currently running a nice series of sessions on vertical projectile motion. We actually started it yesterday and we spoke a lot about a couple of things, but I will somehow also do a recap for today and maybe add with one example thereof. But before I can do that, it is only wise to check how everybody else is doing. Let's just say Lwandlevezi, how is everything, and which maybe topic are you currently busy with at school?
Alyssa, I'm good, thank you. We started vertical projectile motion yesterday at our evening classes. So yeah, that's what we're currently doing now.
Thank you very much. Mr. Tumelo Ditabe,
Hello, sir. I'm okay. We are still busy with organic chemistry.
are you on physical properties or you are just still on naming and structures?
Yeah, we're still on naming and structures. We were doing ester. We stopped at esters.
Okay. No, thank you very much. Re a leboha Thulo.
Good day, sir. Can you hear me, sir?
100% Ria.
Yes, I'm okay. And we started with vertical projectile motion today
Today.
at school.
Thank
Today, sir.
so now you basically says you had a head start from the session of yesterday.
Yes, sir.
Thank you very much. Ladies and gentlemen, let's build on what we have done yesterday. Yesterday, we explained what is a projectile because now combining the topic itself being called vertical projectile motion, it means we must be in a position of us breaking down everything. Vertical basically just means up or down. However, there's a word projectile and there's a word motion. Projectile, we define it now as an object in which has been given an initial velocity and on which the only force acting on it is a force of gravity or the gravitational force. We further said if this is the case, then it means when I am expected to draw a free body diagram, it means when the object is going up, it must still experience now what? Fg, which is the gravitational force. If it is coming down, it will still experience the same gravitational force. Why? Because the condition of an object to be a projectile, the only force acting on it must be a force of gravity. However, the other word is now what? Motion. But in this instance, that motion, we call it a free fall motion. So a free fall is a motion of an object. Which object, ladies and gentlemen? The object which is now a projectile. So it is the motion of a projectile under the influence of a gravitational force only. Ladies and gentlemen, let's be clear. The definition of a projectile is 2 marks. The definition of a free fall is also 2 marks. It's either 2 or 0, ladies and gentlemen. There is nothing in between. The definition of a free fall is also 2 or 0, ladies and there is nothing in between. So just ensure and make your point that you fully understand these two definitions. However, we still need to know the definition of acceleration, definition of velocity, and definition of displacement. Where do we get those definitions, ladies and gentlemen? These definitions are from grade 10. So just try and ensure that when you are in a position of working with a vertical projectile motion, you are actually also understanding the basic concepts of acceleration, velocity, and displacement. Somebody said the e-notes that you shared yesterday, they don't have one equation of motion. And I said, yes, I intentionally and purposefully did so. This, we said this one is our equation 1, this one is our equation 2, this one is our equation 3. Ladies and gentlemen, there's this other equation. It's y is equals to v initial plus v final over 2 multiplied by t. Yes, I understand. It is one of the equations of motion. It is there in the formula sheet. And if it is in the formula sheet, the expectation is we must be able to use it. But this equation, ladies and gentlemen, maybe I should be asking you, when we look at equation number 1, we have v final, v initial, g and y. Equation number 2, v final, vi, g and t. Equation number 3, delta y, vi, t plus half gt. There's something common about all the 3 equations. Any clue, Mr. Ditabe, what common variable is there that ensures that indeed these equations will be more applicable when we work with a projectile motion?
So I noticed acceleration in all 3.
Thank you very much. Because projectile, an object that has been given initial velocity and on which the only force acting on it is now what? The force of gravity. And force of gravity, ladies and gentlemen, relates to g being 9.8 meters per second. When you check the definition of a free fall motion of an object under the influence of gravitational force only, also it relates to g, which is 9.8 meters per second. When you look at this equation number 4 now, it does not have this common factor of g. However, it will still work. Most people and some question papers, memos, everywhere, they still use it. But my advice to you will be, if you can, please try to avoid this particular equation, because this equation does not support the concept of projectile as well as the concept of a free fall. It will work when you have a horizontal motion in most cases, but it is there because it is part of the equations of motion. But if you feel that there is nothing else that you can do, ladies and gentlemen, please feel free to use it. But my advice and majority of the problems that I'm going to do, the first thing that will come to mind is an equation that has g in it. Why? Because g is a condition of a free fall. G is a condition of an object becoming now what? A projectile. Happy Lwandle?
Yes, sir.
Thank you very much. Realeboa, are you still following?
I'm still following, sir.
Thank you very much. Ladies and gentlemen, let's move. I said yesterday, this only page is actually the whole of projectile. That means we are done with this topic. And somebody said, it can't be true. It is only true, ladies and gentlemen, because this is the only things that you need to know. All other things come from grade 10, others come from grade 11. But how are we going to ensure that we close all the gaps within the topic? Is to expose ourselves to how best can we apply the equations of motion. Applying the equations of motion, ladies and gentlemen, it is an easiest way of answering questions in vertical projectile. You will see, but that will happen in June. Once we do a topic that is called work, energy and power, the examiners are going to restrict you to say without using energy principles, without using, then they are forcing you to either use Newton's laws or even equations of motion. But for now, because it is term 1, expect the application of equations of motion. Hence, ladies and gentlemen, I said, how best can we answer the questions? Because the concepts are done. You know what is a projectile, you know what is a free fall. You know that the only force acting on it is the force of gravity, and that's basically it. The problems that will come will enhance the understanding, will enhance now what? The thinking thereof. The first bullet, and mind you, these are my hints that I have derived for myself over the years. Because I will take a question paper or a certain problem and I will also struggle. But because you had to deliver and teach at some instance, we had to develop a way of me understanding such that I can make you to excel and do better. So the way I am doing it, ladies and gentlemen, is I will always draw a sketch diagram of the problem given, label all the important parts of the motion. This thing, they also call it a trajectory. Draw the trajectory of the motion. Choose a direction. Why? Because, ladies and gentlemen, in our equations of motion, we are working with vectors. Choose upward as positive, choose downwards as positive. You must inform and tell the examiner to say, I personally have decided to take upward as positive. So what does that mean? Everything that is going up must be positive. Everything that is going down must be negative. Write down the given variables, the data. That is very, very important. But I said, ladies and gentlemen, for us to perform a calculation, we just need 3 variables, only 3, to get to our answer. 2 variables will be given. 1 variable will be there, but it's hidden. It's either you go and calculate it by using physics principles, or you just understand the principles. And then that is how you are going to do about answering questions of vertical projectile. Then yesterday we spoke about an object that has been dropped from a height. We emphasized that 2 variables will be given. G is a constant, 9.8. It is in the formula sheet, 1 already given. The examiner must give me another one. The examiner decided to give me the 20 meters. So these are now my 2 variables. So 2 variables will always be given. However, now, for me to perform a calculation, I need 3. How do I get the 3? Because I don't know the VF at which it hits the ground. But I am told that the object is dropped from a height. What does a principle of physics say about an object that is dropped? It says the object that is dropped, ladies and gentlemen, it will have an initial velocity of 0. What did we do? We applied here physics principle. So the physics principle assists us to actually get now what? The third variable, which is V initial. If you do not understand what the weight dropped means, it means we are not going to get the V initial that is equals to 0. So we performed this exercise. I'm not going to go deeper into it because I have tried to find another one in which we'll address issues of dropped, and then immediately after issues of drop we will go to type 2 of a problem. So ladies and gentlemen, we spoke about this. So today I am going to give you this one. It says James, let's say it's problem number 2. Problem 2. It says James drops a stone from a bridge that is 20 meters above the water. Ignore resistance. I will just say, for the sake of showing you how important the definitions are, we are going to say define the term free fall. It's not the term, I must just say define free fall. 2 marks. Level of free fall, please.
The free fall.
Yes, the definition.
It's the motion. You.
The motion of an object
Of an object acting.
under the influence of gravitational force only.
Force.
Very, very important. So, ladies and gentlemen, all the definitions are critical. Hence, I'm adding them to the exercises and problems that we are working with. Why do I do so? Because, ladies and gentlemen, believe you me, there is no other way of mastering the science without applying the principles. So I'm just going to say calculate the velocity of the stone when it hits the water. C, I'm just going to say how long calculate how long the stone takes to cover or to fall 20 meters. D, how much above, how high above the water will the stone be after it falls for 1.5 seconds. E, draw velocity versus time graph. Sorry guys, I'm suffering from flu here, but I will be okay. Draw acceleration versus time. Ladies and gentlemen, let's do this one. When we do this one, I said the easiest way of me understanding it is to have a sketch, and I'm going to use the sketch to actually try and explain everything. And then it is being dropped in which direction? Downward direction. And I'm going to commit and say I am taking downward as positive. That is all that I need. Define a free fall. Thank you, Realeboa. Free fall, it must be an easy 2 marks. At B, it says calculate the velocity of the stone when it hits this. So how do we go about that? We write the data. We write down the data. What do we know? Delta y is equals to 20 meters. What else is there? Because we said we need 2. Ladies and gentlemen, G is given, it's 9.8 meters per second. What is the question? V final at which it hits the ground. But we are told James actually drops this particular stone. Apply science principle, V initial is equals to 0 meters per second. You look into your equations. I think the best equation will be V final squared is equals to VI squared plus 2 GY. Now V final, V initial 0, 2 multiplied by 9.8. Remember, everything is going down. Then we get our V final as something like 19.8 meters per second downwards. Very easy. The SI unit is incorrect. Let me correct it. That is the mistakes that we do in an exam. You will think that you did exceptionally well, but in actual essence you did not do well because you got the SI unit incorrect. At C, how long? Same data, V final, VI plus GT, 19.8, 0 plus 9.8 T. When you calculate T is equals to 0.2 seconds. But now, sorry guys. Now there's a problem. What is the problem? The problem is at D, it says how high above. So what is it that the examiner is asking for? Is asking for the height. When the stone has fallen 1.5, so we know our T is 1.5. What is our V initial? 0 meters per second. So delta Y, ladies and gentlemen, is just VIT plus half GT squared, and you just say you 0 multiply by 1.5 plus half of, now what, 9,8 multiplied by 1,5 squared, and then it gives your delta y something like 11,03 meters vertically downwards from the bridge. So we can say vertically downwards, or we can just easily say downwards. Very, very, very important. Now we must draw velocity versus time. Ladies and gentlemen, let me see if I can't just copy this. Just copy this in order for us to work now on the graph. Leboha, are you still following?
I'm still following.
Thank you very much. Your Excellency, Mr. Ditade.
I'm still following, sir.
Thank you very much. Lwanlevezi.
Yes, sir, I'm still with you.
Thank you very much. Now I'm going to try and take it a notch up after this one to give you a platform to actually work on something. And I'm going to see and check before we can go to more of type 2. Let's ensure that we are happy with type 1. So all I'm going to do is I'm just going to remove everything here, and actually draw now my velocity versus time. But now, what was our V initial? Ladies and gentlemen, it started at 0, and then it went up to a certain value. We calculated that value to be 19,8. This is now our velocity, and this is now our time in seconds. How long did it take to hit the ground? 2,02 seconds. And this is your velocity versus time. Remember, this is plus, this is minus. So this is now at E, and then at F. What do we have at F, ladies and gentlemen? At F, we must draw acceleration versus time. So drawing acceleration versus time, we said everything must be positive, and acceleration did not change. Why did it not change? It did not change because it was 9.8 from the top of the building to the bottom of the building. Sorry, to hit the water. So this was 9.8, and this was 2,2, and time now in seconds, and this was just now our acceleration. Ladies and gentlemen, it looks nice and very, very easy for us to actually understand everything that is happening there. Everything that is happening. Everything that is happening. So, ladies and gentlemen, I'm just going to give you one.
So,
Yes, lady.
I wanted to ask there with E where we had to draw the velocity versus time graph.
Mm.
Did it matter if you chose your direction that's positive as down?
That is exactly what we did. We chose down as
Okay.
positive. So just remember, it means the positive axis where y is positive, it actually represents down. And this one will represent now up. But because we chose downward as positive, hence we have a direction that says we are taking downward as positive. So it means our graph can only be positive because when we calculated velocity, we found that our answer is now 19.8 positive. That is the reason why it must be 19.8 positive, because if you draw something like this, it means now basically what you said was you took your downward as negative. That is what you have said, or the choice of direction. Happy.
Uh, Yes, thank you, sir.
Thank you very much. Ladies and gentlemen, let's move and check if we can do something nice also. And something nice will be for you to calculate something. And I'm going to just do this. And then paste this. Ladies and gentlemen, I have this nice question here that I want us to actually interrogate and work with it. So it is just a nice and easy one. So I will give you exactly 12 minutes. Please send your answers. Show by calculations that the velocity of the ball at B is equals to that. It is just an interpretation of the information given. Just work on it and let's see how best you can go about it. So for the next 12 minutes, I will be quiet, patiently waiting for your answers. Thank you very much. Thank you very much, ladies and gentlemen. I am kindly requesting the answers to start coming in. It was just two questions, ladies and gentlemen. You should be able to try something. Thank you very much. Please, let's start sending the answers. Thank you very much. Let's check. Thank you very much. Answers received. One more, please, such that we can be able to discuss.
So,
Hello?
where do we send the answers?
To my personal number.
Oh,
Yes. To my personal number, lady.
and so how do I send? Do I take a picture? How does?
Yes, just a picture will be more than enough.
Yes, I'm coming. I'm taking a picture.
No problem. Thank you very much. Ladies and gentlemen, thank you, thank you, thank you. Let's look into the question itself. The only reason why this question looks to be complicated is because you did not do number one. under the hints. Number one, we said draw the sketch. That is what we said. In all the answers that I received, I did not see any sketch. I did not see any trajectory. Because of that, everything makes it complicated. Why? Because you don't know where you are in the motion of a projectile. So I am going to say I have this. Okay, maybe I must use the tools. I'm just going to say I have this, which will have a certain height, and I am going now to have another one inside, and maybe just have two lines for the purpose of the window. Ladies and gentlemen, you did not draw the sketch. That is where the problem is. A, it's at the top of the building. I am going to add this one here and add this one here. This one here is B, and this one here it's C. But what do I know, ladies and gentlemen? I know that the stone or the steel ball is actually moving down. Then I am going to choose my direction of downward as positive. But what am I told? I am told that the distance here is y is equals to 1.5 meters. Let's read the question again. A steel ball is released from the position of rest at point A. The ball takes 0.3 to move between B and C. So we are also given time here, which is 0.3 seconds. You see, with the window of the length of 1.5, ignore the effects of a resistance. Let's read the question now. The question says, ladies and gentlemen, show by calculations the velocity of the ball at B, you see, is equals to 3.15. We must prove that V initial at B is equals to 3.53. So where am I in the problem? I am going to say at B to C. I am telling the examiner where I am. I have delta y, which is equals to 1.5 meters. I have t, which is equals to 0.3 seconds. Do I have g? Yes, g is a constant, which is 9 meters per second squared. What are we looking for? We are looking for V initial. Why V initial? Somebody will say, why not V final in that number? Because, ladies and gentlemen, if we are looking at the motion of BC, it means it is moving from B to C. And the question is saying at B, not at C. So at C it will be final velocity. That is what the sketch is actually telling me. At C it will be final velocity, but at B it will be V initial. Hence I said, ladies and gentlemen, you need to draw that sketch. Let me go back. Please draw a sketch diagram of the problem given. Label all the important parts of the motion. Label all the important parts. This one, it was nice because ABC was already given. In an exam, believe you me, you will not be given ABC. But it is nice to draw that sketch and you've informed the examiner of what is your thought process in that. Choose a direction. We did that. We took down as now what? Positive. Write down the given variables. We wrote down the data. Only 3 variables are needed. Let's go and check. 3 variables. We have delta y, we have time, we have g. We can perform a calculation. The best equation will be delta y is equals to VIT plus half GT squared. What is y? 1.5. What is V initial is what we are looking for. We are told the time is 0,3. Multiply by half of 9,8, 0,3 squared. Then after performing your calculation, you'll find V initial is 3,53 meters per second. Very nice and easy. Very nice and easy. Then that is now for number 1. But where did we start? We started by drawing the sketch such that we know where we are in what, ladies and gentlemen, in the trajectory of the projectile, such that my data is not lost anywhere, but I know where I am. Let's try and listen to this one. Use relevant equations of motions to calculate height AB. Can you see that now? Where are we? Where are we? We are at AB. That is what the examiner say. So I am going to tell the examiner to say I am at AB. What do I know about AB? I know that when I look at AB, that V initial of 3,53, it must now be my V final. Why? V initial there, V final at the bottom. You see, I know where I am in the diagram itself, in the motion of the projectile. So can I say I have V final? Yes, I have V final, which is 353 meters per second. Is that V initial at B? Do I have delta y? No, I don't have delta y because delta y is actually the question. Do I have g? Yes, I have g. It is a constant, that is 9.8 meters per second. Ladies and gentlemen, I need 3 for me to perform this particular experiment problem. What else can I do? Apply science principle. Science principle will say it was released from the position of rest. What does position of rest mean? V initial is equals to 0 meters per second. V final squared, V initial squared plus 2g delta y. What is that? Very easy, ladies and gentlemen. You just substitute everything you have. 3,53 squared, 0 squared plus 2 multiplied by 9.8 delta y. You solve for delta y is equals to 0,64 meters. I agree. You might have got the answer. But the biggest challenge was, do you actually understand how you got to that answer? So the thought process, it is what I am interested in. The thought process is you actually understanding where you are in the motion of a projectile. So when I said A, B, C, D label, I was actually referring to you understanding where are you in the motion of the projectile. Lwandle, reflections please.
I think today was a very good lesson, sir. I understand a lot better, sir, especially with the first question because I kept on thinking that it was final. So yeah, I think it was a very good session.
Now let's sit down and agree to say the only way of getting things right in this particular topic is not just writing data down, it's actually interpreting each and every question to understand where are you in the motion of the projectile. Because I can add question number 3 and say calculate the total height of the building. You see, it will mean now maybe we can add another section here, and we say let's work with this section, and this section we call it now D. So what will that mean? It will mean we are working with A, B, C, D. So I already have delta y of AB 0,6. I have BC 1.5. So what must I just do? Maybe I can work with CD in order for me to get that particular distance. Then I can easily see that I must add everything together. Or I can just maybe say I am working with ABCD. I am considering the entire motion. It is going to be easy because you exactly know which data to use. Why? You know where you are in the position of the trajectory, the position of the projectile itself. Mr. Ditabe, reflections please.
So I realized where my mistakes were. I also made the same mistake that I thought we were calculating the final velocity, but yeah, I understand now how to get to the answer the next time.
Now, key critical thing, it's the drawing of the sketch. That trajectory, ladies and gentlemen, it is not like I said previously. I was also struggling as an individual, as a learner, as what in my previous life. But somehow I had to develop a way and a mechanism for me to actually master and understand vertical projectile in detail. Because if I myself I have a problem, it means you'll also have a problem. So you are only having a problem because you are not taking the basic principles that I'm saying let's use. The basic principle is let's draw the sketch. Label ABCD. You will not get ABCD in the exam, but have the ABCD. You will see when we do exam problems, the ABCD is going to assist you to say where are you? Where is the examiner asking you all these things? Then you will be able to actually understand. Ladies and gentlemen, re a leboha thulo. Reflections please.
The same, sir. The same. I realized that the applications are very important, like the drawing of the sketch and yeah.
Thank you very much. And tomorrow you will get an exercise for those that are doing projectile. Just in that session in your class, try to draw the diagram first and just check if you are not going to be actually understanding much better. Why? Because everything that I did, I was given this statement of James and everything, but I tried to draw. The only thing that I did not do here was to say this point is A, and this point is B, or that point is B, this one is C. But somehow I must label just for me to know where I am in the motion of the projectile. Ladies and gentlemen, it is exactly 1912. This session is enough because the outcome of the day was reached. The outcome of the day was to actually emphasize how on the application of the sketch and relating your sketch to the problems that have been given. It looked like an easy thing to do, but the science behind it was a little bit complex. Why? Not knowing where you are in the projectile. Ladies